For the first part, magnesium in the gaseous form turned into a magnesium plus one ion in the gaseous form and plus an electron on the right hand side.
Good, good. Gaseous form is the most important part. If you don't write those, you get your marks cut. So very good. Move on, part
Yeah.
B.
Ionization energies decrease down the group due to the increased shielding and the increased distance of the valence electrons from the nucleus. And these two factors outweigh the nuclear charge. So that's why the ionization energy decreases.
Perfect answer. Let's move to C.
Because there's a greater effective nuclear charge. So there is a stronger force of attraction between the nucleus and the valence electron.
Say the second one again.
I'm sorry?
Say your second reason. Say that again. Your first one was about greater effective nuclear charge and
Greater effective
chemical.
nuclear charge, yeah.
The second one
So there
was?
is a greater force of attraction between the nucleus and the valence electron.
Because of?
Because of the increased nuclear charge, so there's stronger force of attraction between the nucleus and the valence electron. So more energy will be required.
All right. Moving on, number 4, question number 4.
First observation, white solid forms.
Right.
Can we mention about vigorous reaction or not?
Actually, no.
Yeah, okay.
Think about one more important observation that you need to make, which is even more important than the white solid or the vigorous violentness of the reaction, the vigor of the reaction.
Do we have to like mention about a flame or something?
Right, flame color, really important. We're talking about barium. It's a very distinct flame color. You memorize that back
What
in
is it?
IGCSE. Apple
Did
green.
we? Oh, apple green, yeah.
Apple green flame color that we memorized back in IGCSE. So we're going to see it over here, since we are taking a barium, small portion of barium and heating it directly in oxygen. Okay. So number 2. Yeah, that's easy. Forget number 2. Let's move on to B, B1.
First of all, calcium carbonate is thermally decomposed by heating it. And we can write the equation CaCO3 into CaO plus CO2. And then we add water to the calcium oxide to form calcium hydroxide. And then we can write the equation again.
Perfect. Okay, since you already have answered part 2, so let's not go with that. Let's not go with part 3 either. Let's look at part C. Yeah, let's start with part C. I hope you understand I'm eliminating any questions for which I know you're either going to answer perfectly or something we're done with already in the previous question.
Yeah. um 4 moles of gallium plus 3 moles of oxygen react to give 2 moles of gallium oxide.
Perfect. 2.
Oxidation number would be +3.
Right. Next up.
For the first part, gallium trichloride, like GaCl3, or
Perfect.
for the first part,
Next.
and second one,
Follow the pattern that we discussed back in
yeah.
IGCSE.
So Na, G, and then OH, and then 4. OH like 4. I'll write it down if I can.
That's fine, but it's actually GA, not G.
Oh yeah, Ga, Na, Ga, and then bracket OH, and then 4 with the bracket.
Good, good. Okay, you can either make the oxide or you can make the hydroxide.
Yeah.
All right, great. So I'm going to continue a little bit with the question that what kind of oxide would then gallium oxide be?
Amphoteric.
Amphoteric. Good. So moving on, question number 5.
Sodium is basic.
Right,
Formula of oxide of aluminium is Al2O3.
right,
For silicon is SiO2,
correct.
and it is acidic.
Mm-hmm.
Phosphorus is P4O10, it's acidic, and sulfur is acidic as well.
Right, good. Okay, let's skip the amphoteric definition, too easy. Ionic equation again, too easy. Right. Action conditions, too easy. Okay, let's answer part 3, just for the sake of practice.
So in reaction 1, hydrogen is forming, but in reaction 2, hydrogen is not forming. So the difference in observation, can we write there will be fizzing in reaction 1 and like no fizzing in reaction 2?
Great. That's what I wanted to hear. Either fizzing or bubbling or effervescence, whatever you mentioned, but it should be on the same pattern, mentioning
All
the
right.
same thing. All right, part 4.
It increases down the group.
It increases down the group. Good. Okay, next one. I guess the question number is not mentioned, but that is definitely 6, I believe.
The outer electrons in magnesium experience less shielding and have a less distance from the nucleus to the valence electrons. So there is greater forces of attraction between nucleus and the outer electrons in magnesium.
Good, good. Okay, let's forget part 2 since that's a simple reaction. Part 3. This one is good.
Strontium is below calcium, right, in the group.
Right.
So the more alkaline solution would be produced by strontium because strontium hydroxide is more soluble, so the concentration of the hydroxide ions would be greater for strontium.
Great. Good. Very good. Okay. Let's skip part 4. We have already done with the observation many times. So look at again, we're done with this. This all seems too easy. Question number 7A, even B, part 1 or 2, either one of them. C, easily answer in relation to bonding. D1 or D2, too easy. Next question. A is too easy. Yeah, let's go with B. Since there are two small explanations, and this also involves group 17 a little bit with the question, I hope you will be able to do it, right?
Yeah.
Okay, let's go with B1 and 2.
So for B1, the melting point increases down group 17 because the ID forces are increasing due to the increasing number of electrons.
Good, very good. Part 2.
And for group 2, the melting point explains, so because the metallic bonds are getting weaker, because the size of the ion is increasing, so the charge on the ion is much more spread out.
Right. Very good. Okay, let's see C. Okay, let's go with C. Although that's not too difficult, but let's practice since it's new.
For reaction 1, We need nitric acid.
All right.
And reaction 2, we need water.
Okay, what if the question
Water.
was changed to state the reagent along with the conditions needed for each of the reactions 1 and 2? What would you add in terms of conditions to both the reactions?
Okay, so nitric acid, concentrated. Would that make any sense? Nitric acid.
Okay, what about reaction 2?
I think water.
So that's the reagent, but what about the condition? Are you going to increase or decrease the temperature? Any other kind of changes you require?
I think barium can react with the cold water like easily.
If barium can react with cold water easily, why do you need concentrated acid?
Does it really matter if you have like dilute or concentrated?
The rate of fizzing would be different, but
Yeah, the
actually
rate would be different, but
barium can react with both. So that's why he never asked for conditions, because it really does not matter if we use concentrated or dilute acid, barium would react. Since barium is a reactive metal, the reaction would easily go with water as well.
Yeah.
Makes sense why they're not asking for conditions. Okay, no need for 2. That's too easy. Let's see what we have in 3. Let's go with 3.
All right.
It's been some time since we have practiced a question like this one, so let's go with 3 as well as 4.
We have nitrogen dioxide and oxygen will be formed, and we'll see nitrogen dioxide will be formed. So brown gas. Brown gas will be observed, which is nitrogen dioxide.
Right.
And oxygen would be formed, which is a colorless gas basically.
Good. Okay, 4.
A white precipitate would be formed, which would be barium sulfate. Because this is a precipitation reaction, right?
It is. You're right.
Soluble salts react to form one insoluble salt and a soluble one. So a white precipitate forms, which is barium sulfate.
But since it is of 3 marks, there is one
we'll
more thing we need to go with.
So barium will display, not displays what?
And remember, all 3 marks are for observations. So as soon as you say white precipitate and you explain that it is for barium sulfate, you get your 2 marks is covered. But what about the third one? And remember, this has to be an observation. It can't be a chemical
Magnesium
explanation.
hydroxide.
And what about it?
Slightly soluble.
Is slightly soluble. Right, good. Actually, in this case, yeah, we do tend to form one insoluble salt and one soluble salt, which usually are the cases for precipitation. But notice that even the soluble salt is very slightly or sparingly soluble in this case, which is magnesium hydroxide. So yeah, this was a little bit different. That's why they asked for these observations. Okay, next up. I don't think there is anything in this entire question that would give you a challenge, right? Be it part one, two, or
Yeah.
three. These are too easy. So let's move on to the next one. Is cerium. I'm not going to go with A1. You will easily be able to draw a metallic bonding diagram. You have been doing that since IGCSE, so it shouldn't be a problem for you. So neither the physical properties, too easy. Oh, the question ends. I was actually excited about a question for a lengthened element, but too easy. Okay, moving on to the next one. Entire part A is too easy. I've practiced many questions like these. Okay, B1. Let's go with this one. B1 is good. We should do it, as well as B2.
All right.
And B3. We need to completely cover B part. All questions are new.
Do we mention about the activation energy in the first part?
Exactly.
Because
Exactly.
yeah, because the activation energy isn't provided, so the reaction cannot start off.
Right. Right. B2. This was actually a part of IGCSE, so this shouldn't be a problem.
Yeah, high melting and boiling point due to the strong electrostatic forces of attraction between the oppositely charged lines.
Right. Number 3.
And for the third part, it would react with the acidic materials to, yeah, it will react with the acidic materials.
Why?
Since magnesium oxide is basic.
Okay. Great. Moving on. C1.
Temperature, it increases.
For both, since it's asking about
Yeah,
nitrates and carbonates.
yeah, for both.
For both. Good. Let's leave 2 and 3. You'll easily be able to do it. Finally, a flowchart question. Go ahead. Since this is our first flowchart question with so many options, so let's try it out.
A would be MgNO3 twice. B would be hydrogen.
Right.
C would be nitrogen dioxide. And D would be oxygen.
Right. Okay. 13 is too easy. Yes. Let's go with 2, 3, and 4. Actually, 2 and 4 I want to definitely emphasize. So 13A2.
Mg plus H2O reacts to give magnesium hydroxide plus hydrogen. And it turns cloudy because the magnesium hydroxide formed is slightly soluble.
Right.
And for the fourth part, magnesium plus H2O gaseous form, we can write it will give us magnesium oxide only.
Uh-huh. So where would the hydrogen go?
I don't think there is hydrogen, is it?
But water contains hydrogen, even when it's in steam form.
Yeah, but the thing evaporate, it's hot steam, so hot.
So Mg plus H2O is supposed to just give you MgO, and you won't even balance hydrogen on both sides.
Okay, yeah, I think
It does
yeah,
give you
plus.
hydrogen. The only difference is that magnesium hydroxide is formed in part 2, magnesium oxide is formed in part 4. But both parts do give you hydrogen gas.
All right, yeah, I forgot. Okay.
Okay, so too easy. One, two, and three are too easy. Go for four. Although four is also easy, but at least
Okay,
slightly
4.
different.
The element nitrogen is reduced since its oxidation state changes from +5 to +3.
Okay.
Yeah, that's all I'd say for 3 marks. Identify the element and oxidation state change.
But the question specifically says one
Oh, it's
element is
oxidized too.
reducing and another one is oxidizing as well.
Yeah, for oxidized it would be oxygen because its oxidation state changes from -2 to 0. It increases.
Good. We're done with the next question. Let's leave it out. As well as the next one. And let's try this part 2, the last question on the page. I need question 1.
Is it 2H plus CO3 2 minus? It actually
Right.
give carbon dioxide plus water.
Right. That is correct. Carbon dioxide plus water. It is going to form carbonic acid, but since they have specifically mentioned it's a neutralization reaction, so you can't write the acid as a product. Definitely, that acid is an unstable acid and quickly decomposes to give us uh, water and carbon dioxide. And neutralization reaction also produces water along with the salt. That though that's not the case with the salt, but that definitely conforms somewhat with the answer. So the answer should not contain
Yeah,
carbonic acid, instead water and carbon dioxide. Let's skip the moles part. Too easy. We're done with this before. Now, since I've
yeah.
recently asked you to react magnesium with water and steam, easy. Let's not go with this. Steam. Though that's so far the biggest flowchart that I've seen, but again, it's way too easy. Part C. Read out part C, then I'm
Let's
going to take
see.
you back to the flowchart that you can answer the question. That's what I was just doing.
All right.
I'm going to ask you to do the same. Okay, so suggest the
Yeah,
formula of
I've
an
read it.
aqueous reagent other than an acid for reaction one. Your answer can't be an acid.
Yeah, anything other than okay. Reaction one.
So you might need to
Okay.
solve
Yeah, I need to
almost
solve it.
half of the flowchart in order to get it right. Go ahead, take
Yeah,
your
okay,
time.
just give me a bit. Yeah, so we can use magnesium sulfate.
Magnesium? Why would you prefer magnesium? Don't you think you should go for something reactive?
Yeah, okay.
Try going for something more reactive. Though magnesium is also a correct option. I'm not saying it's wrong, but since you have been answering your question so perfectly, so try going for something more reactive than this.
Maybe um potassium sulfate or rubidium sulfate.
Right. Anything from group 1 would be better because group 1 is more reactive than group 2 usually. So anything from group 1 would work better, but anything doesn't mean you pick the first member of the group. Lithium is not going to cut it. So
Yeah.
anything below would do better. So going for potassium or for rubidium is a great choice.
Got
It's a moles question. Let's skip this one. Let's skip this entirely. Okay. The same thing, but this time we're doing it with calcium. Same. And this finishes the chapter.